Introduction: something massive has arrived. November 11th, 2025, something massive just crossed into our solar system, and the numbers coming from observatories worldwide are making astronomers question everything they thought they knew about interstellar visitors. An object traveling at 137 miles per hour, leaving a trail of mystery in its wake. The third confirmed visitor from beyond our solar system, but this one's different. Bigger than anything we've detected before, behaving in ways that don't match the textbooks, and arriving with a cloud of controversy that has scientists divided and social media exploding with theories. Some say it's just another comet. Others point to data that suggests something far more complex. What we know for certain is this: the object's here, it's active, and what happens next could rewrite our understanding of what travels between the stars. Discovery, July 1st, 2025. July 1st, 2025, the Atlas telescope system in Chile, designed to scan the skies for threats to Earth, flagged something unusual. An object designated A11P13Z appeared in the data feeds, approximately 410 million miles from the Sun, moving through the constellation Sagittarius. Within hours, astronomers worldwide were scrambling to get eyes on this thing. The initial magnitude reading came in at 18. Faint enough that you'd need serious equipment to spot it, but bright enough to confirm something real was out there. Rediscovery images started surfacing almost immediately. Archives from the Transiting Exoplanet Survey satellite showed this object has been visible since May 7th, 2025. We just hadn't noticed it yet. The Zwicky Transient facility at Palomar Observatory had captured it in June. This wasn't a sudden appearance. It had been approaching for months while we were looking elsewhere. Confirmation: interstellar object number 3. By July 22nd, 122 observations from 31 different observatories confirm what the Atlas teams expected. This wasn't from our neighborhood. The Minor Planets Center assigned it dual designations: 31 Atlas for interstellar object number 3 and C2025N1 for comet classification. The I in the name tells you everything. Interstellar. Not born here, not bound to our sun, just passing through on a journey that started light years away. The discovery process moved faster than any previous interstellar detection. Within 24 hours, major space agencies, including NASA and the European Space Agency, had confirmed the trajectory and ruled out any collision risk with Earth. The object would pass us safely, but it would get close enough for detailed study. First observations: an active object. The Lowell Discovery Telescope, the Canada-France-Hawaii Telescope, and amateur astronomers with backyard setups all started feeding data into the global network. What emerged from those first observations stopped the astronomy community cold. This thing had a coma, a cloud of gas and dust streaming away from a central nucleus. It had a tail. It was active, outgassing material as it heated up from approaching the sun. Comets do this naturally, but interstellar comets are rare enough that every detail matters. Only 2 others had been confirmed before this: Oumuamua in 2017, which sparked years of debate about its cigar shape and strange acceleration, and Borisov in 2019, which was clearly a comet but chemically weird. Now we had number 3, and the data coming in suggested it was the most complex visitor yet. Size estimates: the largest interstellar object ever detected. Size estimates started conservative. Early calculations based on brightness and distance suggested a nucleus somewhere between 1,444 feet and 3.5 miles across. The Hubble Space Telescope got involved on July 21st, imaging the object from 277 million miles away. The images showed a teardrop-shaped dust cocoon wrapping around the nucleus. But when the Vera C. Rubin Observatory trained its instruments on the target, the numbers changed. Their analysis suggested something closer to 7 miles wide. That's massive for an interstellar object. For comparison, Oumuamua was maybe 200 meters long. Borisov was estimated around 1 kilometer. This thing, if Rubin's numbers hold up, is roughly 11 kilometers across. That makes it the largest interstellar object ever detected entering our solar system. Objects this size don't just drift between stars unnoticed. They're planetary building blocks. Mountain-sized chunks of ice and rock that survived the violent formation of some distant solar system and got ejected into the void. Velocity and origin: billions of years in transit. The speed data added another layer. At discovery, this object was moving at 61 kilometers per second relative to the Sun. That's 137,000 miles per hour. By the time it reached perihelion, its closest approach to the Sun on October 29, 2025, it peaked at 68.3 kilometers per second. These velocities are consistent with something that's been traveling through interstellar space for potentially billions of years. Simulations traced its past encounters with 25 stars within 1 parsec over the last 10 million years. Each encounter would have slightly altered its path through gravitational interactions, sending it on this precise trajectory toward our solar system. The odds of this happening randomly, of an object this size entering from the galactic plane with this exact velocity and angle, are astronomical. The word gets used a lot in these discussions, but in this case it fits. Trajectory, a hyperbolic path through the inner solar system. The trajectory itself raised immediate questions. The orbit's hyperbolic with an eccentricity of 6.1374. Any eccentricity above 1 means the object isn't gravitationally bound to the Sun. It pass through once and leave forever. The semi-major axis is negative, another signature of a hyperbolic path. The inclination is 175.11 degrees, which means it's moving retrograde, opposite to the direction most solar system objects orbit. It's tilted just 4.89 degrees from the ecliptic plane, the flat disk where planets orbit. This is unusual for interstellar objects, which can come from any direction. The fact that it's nearly aligned with our planetary plane suggests either an incredible coincidence or something about its origin we don't yet understand. Its perihelion distance was 1.356 astronomical units inside Earth's orbit but outside Venus. Closest approach to Earth happened on December 19, 2025 at 1.798 AU, roughly 170 million miles. No danger, but close enough for detailed observation. Planetary flybys threading through the solar system. But here's where it gets strange. The object had close approaches to multiple planets. On October 3rd, it passed Mars at just 0.19 AU, close enough that Mars orbiters, including ExoMars, Mars Express, the Mars Reconnaissance Orbiter, and China's Tianwen-1 could image it directly. These observations are still being analyzed. On November 3rd, it passed Venus at 0.65 AU. Looking ahead to March 16, 2026, it'll pass Jupiter at 0.36 AU before leaving the solar system entirely. These planetary flybys aren't random. The object's path threads through the inner solar system with precision that's mathematically fascinating. Natural objects can do this. Orbits are deterministic and predictable. The sequence of close passes during a single transit through our system is rare enough that it's drawing attention from orbital dynamics specialists. Composition, chemistry from another star system. When the James Webb Telescope analyzed the object's composition on August 6, 2025, the results didn't match standard comet models. The spectroscopy showed massive amounts of carbon dioxide, about 129 kilograms per second being ejected from the nucleus. Carbon monoxide followed at 14 kilograms per second. Water, the dominant volatile in most solar system comets, was only producing 6.6 kilograms per second. That ratio's backwards. In our solar system, comets typically show water as the primary outgassing component, with CO2 as a minor constituent. This object has 8 times more CO2 than water. The Very Large Telescope in Chile confirmed the findings and added more details. They detected cyanide, nickel, carbonyl sulfide. The nickel detection is particularly interesting because it suggests the comet contains metallic components in its dust, materials that formed in the disk of another star system under different chemical conditions than their own, formation conditions beyond the CO2 frost line. The composition suggests this comet formed in a region of its home star system beyond what astronomers call the CO2 frost line, the distance where temperatures are cold enough for carbon dioxide to freeze solid. That's farther out than where most comets in our system formed. It also suggests the parent star system might have been metal poor compared to our Sun, with different abundances of heavy elements affecting what materials condense during planet formation. Analysis of the polarization of light reflected from the dust coma showed similarities to trans-Neptunian objects, the icy bodies in the outer reaches of our own solar system. This could mean the formation conditions weren't completely alien, just shifted in temperature and composition. Age older than our Sun. Age estimates from the nucleus range from 3 to 14 billion years based on the degree of processing visible in the surface materials. Our solar system's 4.6 billion years old. If this object is toward the older end of that range, it's literally older than our sun, formed around a star that may no longer exist, surviving supernova shock waves and the radiation environment of open space for epochs. The surface shows signs of cosmic ray bombardment, radiation damage from high-energy particles that only accumulate during long exposure to interstellar space. This isn't something that happens to objects protected within a solar system's heliosphere. This is the signature of billions of years in the void. Coma structure, bizarre jets and asymmetric behavior. The coma structure is equally bizarre. Hubble images show it's not symmetrical. There's a massive plume shooting toward the sun, the wrong direction for normal cometary behavior. When comets heat up, material typically jets away from the sun as ice sublimates on the daylit side. This object's also doing that, but it has active regions facing the sun that are producing enormous jets. Recent observations show one jet extending up to 285 million kilometers, longer than the distance from Earth to the sun. The anti-solar tail, the dust trail pointing away from the sun, stretches roughly 100,000 kilometers. The coma itself is elliptical, not spherical, measuring up to 26,400 by 24,700 kilometers. All of this is evidence of violent outgassing from a rotating nucleus with active regions concentrated on specific areas of the surface. Physical characteristics: color, rotation, and dust ejection. The object's color is distinctly red, similar to Kuiper Belt objects in some long-period comets. The dust grains in the coma are several micrometers across, larger than typical cometary dust. Small grains measuring less than 1 micrometer are also present, creating a size distribution that suggests different ejection mechanisms or multiple active regions with different volatile compositions. The rotation period is estimated at 16 hours based on brightness variations, meaning the nucleus is spinning relatively fast for its size. That rotation creates the asymmetric jets as different regions face the sun and heat up in sequence. Dust ejection rates measured in early observations show about 6 kilograms per second of small particles and 60 kilograms per second of larger particles. It's a lot of material for a nucleus this size, suggesting either a very active surface or an internal structure that's allowing subsurface volatiles to reach the surface easily. The natural explanation: an extreme but normal comet. Mainstream astronomers argue that these characteristics all fit within natural comet behavior, just at the extreme end of what we've observed. High CO2 content can be explained by formation distance from the parent star. The size is unusual, but not impossible. We've just never had the instruments sensitive enough to detect large interstellar objects before. The jets in asymmetric coma are consistent with rotating nuclei with discrete active regions. This interpretation treats the object as an opportunity to study extrasolar planetary formation, a sample of materials from another star's protoplanetary disk delivered to our doorstep. The data supports this view. Multiple independent observations from space and ground-based telescopes all show cometary activity: sublimation, dust ejection, coma formation, tail development. These are all the hallmarks of an icy body responding to solar heating. Alternative theory: a monitoring probe. However, this doesn't explain all the observations. Some researchers suggest this could be a probe, a monitoring device sent to observe solar systems with active planets. The trajectory brought it through the inner solar system during a period when Earth's technological civilization is at its most detectable. Our radio emissions have been propagating outward for over a century. Our atmosphere shows industrial pollution signatures visible through spectroscopy. If this object's been watching us since it entered the Kuiper Belt, it's been in a position to study human civilization at a critical moment in our development. The size would be necessary for long-duration missions: propulsion systems, power generation, shielding from radiation, and impacts during millions of years of travel. The composition could be camouflage, an outer layer of ice and rock hiding internal structure. This theory acknowledges the cometary activity is real, but suggests it might be a design feature rather than proof of natural origin. Extreme speculation: an artificial vessel. A handful of researchers are considering something more dramatic. What if this isn't just an observation mission? The energy requirements for accelerating something 11 kilometers across to interstellar velocities are immense. If this object is artificial, it represents a level of engineering capability far beyond anything humans have achieved. The power output from the jets, if you calculate the energy needed to sublimate and eject that much material, is substantial. Natural comets get this energy from the sun heating their surface. An artificial object would need onboard power generation. The jets themselves could serve multiple purposes: course correction, waste heat dissipation, raw material processing. The size suggests this could be a vessel designed for transport, possibly a colony ship or resource hauler moving between star systems. The rotation could be intentional, creating artificial gravity in interior spaces or optimal orientation for propulsion systems. The planetary close approaches could be gravity assist, using planetary masses to adjust trajectory without expending fuel. The timing question: response to human activity. Others point to timing. Human technologies crossed several thresholds in the last few decades. We've sent probes beyond the heliosphere. We've launched space telescopes capable of detecting exoplanet atmospheres. We've begun serious searches for technosignatures in other solar systems. We've demonstrated nuclear weapons and planetary-scale environmental modification. If this object arrived in response to something we did, that suggests a monitoring network already in place, automated systems triggered by specific observables. Humans crossing from a planetary civilization to a spacefaring one might be exactly the kind of development such a system would flag. This frames the object not as exploration but as response, a check-in to see what's developing in a previously quiet corner of the galaxy. Historical context, ancient records and previous visitors. Interestingly, ice core samples from Greenland and Antarctica show layers corresponding to unusual atmospheric conditions during periods when Earth would have been visited by large comets in previous epochs. Some of these layers line up with extinction events, climate shifts, or periods of rapid cultural change in human prehistory. Ancient records from various civilizations describe bright objects in the sky, some with multiple tails, some appearing and disappearing over weeks or months. Archaeological sites like Göbekli Tepe in Turkey, built over 11,000 years ago, contain carvings that some interpret as astronomical charts tracking celestial events. If interstellar objects pass through our solar system more frequently than we realize, and if some of them are large enough and active enough to be visible to naked-eye observers, they would absolutely have been recorded by ancient cultures. The connection between these records and specific objects is speculative at best. Mainstream archaeologists remain skeptical of attempts to link megalithic sites to astronomical events beyond simple solar and lunar calendars, but the timing is difficult to ignore. The information blackout, observatories go quiet. Major observatories have gone unusually quiet about certain aspects of this object. Scheduled observation windows at several facilities were mysteriously blocked during the October approach. Requests for telescope time to study the object during its closest passes to Mars and Venus were denied without detailed explanation. Public data releases that should have been routine for an object this scientifically significant have been delayed. Internal communications obtained by independent researchers suggest that some observatories received guidance to limit public statements about the object until after perihelion. The justification given was avoiding public panic, but the effect was a gap in information during the most critical observation period, from late September through early November, when the object was at its brightest and closest. Official channels were notably restrained while amateur networks filled the gap. Professional frustration, the cost of restricted information. Off-the-record conversations with professional astronomers reveal frustration with this approach. Several researchers have privately expressed concern that limiting information flow during active observation periods sets a dangerous precedent. Science thrives on open data sharing, peer review, and the rapid dissemination of findings. When institutional gatekeepers decide what information is appropriate for public consumption, it undermines trust and creates the exact conditions where conspiracy theories flourish. The blackout wasn't total. Data continued to flow through academic channels, papers are being prepared, observatory archives will eventually be public, but the weeks when the object was most accessible coincided with the most restrictive information environment. Grassroots networks, amateur astronomers fill the gap. This created an opportunity for grassroots observation networks. Independent astronomers, many with sophisticated equipment purchased through amateur channels, coordinated observation campaigns through online forums and encrypted communication channels. These networks have been growing for years, partly as a hobby, partly as a response to perceived gaps in institutional astronomy. When professional observatories went quiet, the amateur network picked up the slack. Observers in the southern hemisphere, where the object was best visible during approach, shared raw image data within hours of capture. Spectroscopy from modified commercial telescopes provided composition data that matched what the big instruments were seeing. Photometry tracking brightness changes and jet activity gave real-time updates on the object's behavior. Distributed observation, science without institutional approval. One coordinator in particular, a researcher known in the community for open-source orbit calculation software, put out a call across public forums. Keep your scopes on the sky, log every observation, share the raw data before it disappears. The response was immediate. Within 48 hours, a distributed network of observers spanning 3 continents was feeding data into a collaborative database. The information wasn't perfect. Amateur equipment has limitations that professional observatories don't. But volume compensated for individual precision. Hundreds of observations from dozens of locations provided redundancy and confirmation. When one observer reported unusual brightness fluctuations, 5 others could verify or debunk it within hours. This approach proved that important scientific work doesn't require institutional approval or million-dollar budgets. Current status fading into the distance. As of right now, the object is moving away from the Sun, still visible but fading as it heads back toward interstellar space. Current position is beyond Earth's orbit, continuing on that hyperbolic trajectory that will eventually take it out of the solar system entirely. Brightness has dropped from its October peak of magnitude 12, visible in good amateur telescopes, to fainter magnitudes requiring larger instruments. The next critical window won't open until March 2026 when it passes Jupiter. That flyby will be the last chance for detailed observation before it becomes too faint and too distant for anything but the largest professional telescopes. After that, it'll fade into the background of space, one more dim point among billions, undetectable without knowing exactly where to look. Analysis ongoing, months of work ahead. The data from the December Earth approach is still being processed. Multiple observatories, both professional and amateur, captured high-resolution images and spectra during that period. Analysis of data will take months. Papers are being written. Findings are being peer-reviewed. Databases are happening in conference rooms and email chains. What we learn from this object will inform our understanding of interstellar chemistry, planetary system information, and the frequency of large objects passing through the galaxy. It will also test our ability to respond scientifically and socially to anomalous events. The conspiracy theories, the viral claims about 100 times larger companion objects targeting this comet, speculation about alien spacecraft, all of it demonstrates how easily misinformation spreads when official sources are silent and social media fills the void. Multiple interpretations. What does the data mean? The object exists, that much is confirmed. The size, composition, trajectory, and behavior are all documented in astronomical data from credible sources. The interpretation of that data is where opinions diverge. Natural comet from another star system, delivering a sample of extrasolar materials for study. Artificial probe on a monitoring mission, checking in on Earth's development. Vessel traveling between stars for purposes we can't yet determine. Warning or response to human activity, triggered by thresholds we've recently crossed. Each framework has evidence supporting it and gaps that remain unexplained. The scientific community favors natural explanations because they require fewer assumptions and fit existing models. But the gaps exist regardless of interpretation. The unusual composition, the alignment with the ecliptic, the sequence of planetary flybys, the timing of discovery during a period of rapid human technological advancement, all of it invites questions. Conclusion, the story continues. Whatever this object is, it's not finished. The story continues as it moves through the outer solar system. More data will emerge, more analysis will be published, more observations will either confirm or challenge current theories. The answer won't come from authority figures telling us what to think. It will come from continued observation, from comparing notes across institutions and amateur networks, from following the data wherever it leads. When the next piece of the puzzle appears, it won't be announced in a press conference. It will show up in someone's telescope, get logged into a database, get shared across networks of people who care enough to keep watching, even when the official channels have moved on to other things. The object arrived, data exists, the questions remain open. Keep Keep watching the sky.